Hello, great to be here. Thanks for inviting me to this awesome cinema, and I've been a lot of time in Greece actually, especially when I was younger, but I haven't been here for a while, and it's really cool to be here. And I enjoyed my evening yesterday in Thessaloniki very much. So, yeah, my name is Timo, and yeah, my company is called Timo, and yeah, we run microservices in production for a number of customers, and I just want to share with you a little bit of the experience we made with that, and it's my truth, it's probably not your truth, and I'm not telling the truth, but I'm telling my truth and try to share that with you. And yeah, what do we do? I mean, we have at Timo, we're a distributed team across Europe. Sadly, we don't have anybody working from Greece for us, but we have people in Spain, in Czech, in the Netherlands, in the UK, and we're like remote first. So we work from home, or we have an office in Cologne in Germany, but and yeah, we run like Kubernetes as a service for our customers on-prem in their data centers, but also we have our own data center in Frankfurt, which is like more a self-service Kubernetes, and yeah, we can also run in like different cloud environments, and that's what I'm gonna talk to you about today. I just have like a brief introduction to microservices because I think they're like it could fill a full talk to just talk about the architecture principles, and so I just give you a brief introduction to it. So first of all, it's not a holy grail. It doesn't solve all your problems, and maybe microservices are not the right thing to do for you. You have to decide if you have something that scales vertically on one machine and that's all you need. Maybe that's the better option than scaling it out on multiple machines and having lots of more problems. So think about it before you start using microservices just as the hammer for everything, And to me, it's also more like a mindset than like a concrete architectural pattern. I mean, it has like architectural parts that you will find in like each and every microservice environment. But each and every microservice environment also looks completely different from the other one. It's more like a habit how you develop your services and what kind of things you do. For instance, use the right tool for the job. And you can only do that if you have a small service that has one purpose. Then you can choose the right tool for the job. And maybe it's a different programming language, or maybe it's a different database, or maybe you're using not an HTTP interface, but using message queues, and you can just decide on this technology for each and every component, and that's the mindset. So before you start developing a service, you look at what are the needs for this service, how many writes do I have in this service, and maybe the database I'm always using in the other service, which is Postgres, doesn't fit here, and I need to look into something else like Cassandra or some other NoSQL store, and that's you can find that under the polyglot principle. So you choose the right database for your service. And obviously, if you have a zoo of things running in your data center, you really need to automate it. And this is like the whole DevOps movement. So you have like a cross-functional team, and you have DevOps inside of that team helping or working together with the developers to actually automate the full deployment, speak against cloud APIs, etc., so that you can ship your software fully automated and it's repeatable, and that's, you know, it's a kind of mindset you need to be successful with microservices. And yeah, obviously the practice of, you know, shipping something early and then measuring it and learn what's going on with that service and then adapt it, iterate on it is like a core principle. And you know, at some point, because it's such a small service, you can just throw it away and do the second implementation of it because you made some mistakes, some false assumptions in the beginning, and choose the wrong technology, stuff like that. So that's like a mindset for me behind microservices. And yeah, the benefits are, yeah, you have separation of concerns, you don't lock your teams, like for instance, in a big code base, you know, then you have like one staging environment, so team A is just developing something, putting it on stage, and then, you know, team B is ready, but they cannot because the other team is blocking, and so it's much more complicated to work together in a big code base with multiple teams, and having those teams owning different services is much easier. Obviously, you also have the problem that you have like dependencies where between the teams because of the APIs of your services, but then you have like practices like versioning your APIs and stuff like that to make this like less blocking between the teams. Yeah, you can have independent technology decisions. That's what I already said before, and yeah, you should be able to iterate faster. But it's not free lunch, which means the automation that comes with it adds a significant amount of manpower and time. So in the company I've worked before, we built a microservice stack on AWS 5 years ago, and I think we had like 20 to 30% of the team working on automation, and that's a lot. I mean, if 20% of your developers that should actually you know, implement functionality like business logic are working on the meta stuff, which is, you know, automating all the infrastructure. That's a lot of overhead. But it's getting better with like all the open source tools we have nowadays, with Docker, with Kubernetes, with the products from HashiCorp. Those things get way easier. I think the first generation of config management was a little bit more yeah, time-consuming, especially if you wanted to have like good quality. And yeah, one thing is that the complexity doesn't go away. That's you're just moving the complexity somewhere else. So you still have the same complexity, and microservices do not help you, and also containers do not help you to get rid of the complexity. So either you move some complexity of the distributed system into like the container stack, the orchestration, but still somebody needs to manage that for you. And then you also have like cohesion and coupling between your services, and there's still complexity in there. But each team can focus on just one part, and that makes it easier, but in a whole, it's still a complex system, if it's, you know, a complex system in a monolith. So it's not going away. You know, and then we definitely have like resilient global distributed services, and everything works, you know. No, you have to ask yourself the same questions you have to do if you do microservices or not. You have to think about what you're doing, and you have to evaluate your decisions by, you know, going through the questions, you know, what is applicable, what's the right thing to do here, what are the requirements, and not only the business requirements, but also the non-functional requirements that lead to some technology decisions, and you need to look, what do I want to build, or what do I need to build? And that's very important, and that's why I think, yeah, it's more like it's a pattern, it's a practice, it's the mindset to have these kind of small services, and it really depends on you how small you do that, and maybe you learn with it. You do build, measure, learn with your services. How big are they? I mean, that's the common question I get. Like, how big should my microservices are? That really depends how far your team is in the culture of building those kind of services and managing multiple technologies. And it's not about like a simple architectural question. It's more about, you know, communication structure in your team, capabilities in your team, experience in your team, and so on, with handling such an infrastructure. And looking at the infrastructure, we now have like APIs everywhere. That's fantastic. I can just, as a developer, which I mean, we're doing infrastructure, but I still think that I'm a developer and not a sysops guy. And you know, I can orchestrate storage, networking, cloud compute. That's all there, and it's not only there in like AWS or GCE, but also a lot of tools that allow you to do that in your own data center or just on your laptop, and that's fantastic. Or in your house. I come to that later. And yeah, everything is code. And the other thing is, and that's you know, an experience I made with the first generation of config management, where stuff was written in code, more or less not in Dash, but in some programming language, but still it was imperative code that was executed when the server was started to actually provision the server. And sometimes that failed. And it was like rather, you have these systems that run idempotently, every couple of minutes on your machine to actually get it to a state. So you're really good at managing what should be there, but you're not managing what shouldn't be there. And also, after some time, you think you have a cluster of machines that should be identical, but they're not, because you forgot to pin that library. So if you don't have an immutable server image or a container image, then at some point your cluster that should be identical isn't, and it's going to hurt you. And what I find really important is to have a declaration of your infrastructure. So you have like a Docker Compose YAML, or you have a Kubernetes manifest, which is saying, okay, I'm starting this image, and this is reproducible on my laptop, on the production environment, etc. And I also have these policies for, I don't know, my networking, my storage, and so on. So these things just get applied. Obviously, there's also code involved, but this code is coming from like big open source products. There are tests in there, and it's not that you write your own recipe to deploy something. And one other thing is having primitives instead of frameworks. Don't layer it away. Don't have like a pass that hides everything from you and then covers like 80% of the use cases, but that that use case need to be scaled more, and then suddenly the pass is just in your way, and you're poking through the layers and trying to get the pass do the thing you wanted to do, and this doesn't help. And this is actually from Werner Vogel's when he had a recap of like 10 years AWS. He said like our experience is primitives over frameworks. Just have the right primitives available, and then people start using it and mixing it and do their own thing, because the people are always right because they have a use case that's different from your use case, or what you think what the use case would be. Yeah, so this is just an example, and I don't want to explain it. I think there will also be a talk about Kubernetes later. So it's just an example that there are multiple components involved in Kubernetes. So you have a master and a worker, and there are multiple things running on the master. And if you add, so down there, there are some log forwarder, metrics collectors, things you usually need. This is like networking and applying networking policies. And in the same year, you also have a metrics collector and log forwarder, but then you also have like the Kubernetes components. So it's already a couple of services you're running. And if you then look at, for instance, the monitoring, that you again have like a couple of components running there. You have a push gateway. You maybe you have the alert manager that sends out alerts. You have something like Grafana, and then Prometheus is also talking to your container orchestration. So it also adds a couple of services. And if you then look at like a bigger on-prem deployment where we actually spawn multiple Kubernetes environments with a thing called the giant Netis, which is also a Kubernetes. So we're spawning Kubernetes with Kubernetes, and you have like our API services around. Do you see? This is only the infrastructure, and so the problem is it's a chicken egg problem. You have like microservice infrastructures are microservice infrastructures itself, because it's all software, and the nice thing would be to apply the same things to the infrastructure. That's why we're actually using Kubernetes to deploy the customers' Kuberneteses, because we didn't want to use something else for it, because we know for a reason why people should use Kubernetes, and that's sometimes a bit of a stretch. And you never, really get rid of the chicken egg problem. But yeah, it's just that we as a company that gives microservice infrastructures to other companies are also doing microservices, and so some inception. And yeah, obviously that was when the SRE was born. If you haven't read this book and are interested in like system, so development that is close to the system, so not being a sysadmin but being a developer, actually developing infrastructure, this is a really good book to learn about how Google does that, and I can really recommend this. So I think the most important thing about microservices in production is having good metrics, and having like metrics first. So you want to be data driven. You want to understand what's going on to actually make some decisions. So you DevOps, you build it, you run it. And an interesting question is, if you look at all the open source tools that are out there, it's actually not something I own. So usually if I develop a microservice, I as a team own that service, and so we continuously deploying it like every day, multiple times, and it's our code, it's our service. But how do you do that with all the open source software that's out there? Yeah, and my example is my home, because I have, I live in Germany and it's cold in the winter, and I have this like 30-year-old heating that sometimes is really not doing what I want it to do. And I had like a major failure last year, and then a guy coming in and installing a new one, and I fixed some things where I thought, there are some inefficiencies, and a couple of months later, I thought like, yeah, I will get back a big check, because they fixed it, it's a new one, it's much more efficient, it's much better, but it wasn't. It was the same. I was paying the same thing, but I actually thought I fixed it, and I was like, fuck, I don't have a clue what's going on with my heating, and I cannot even make good decisions on it. So I applied the same principles to my heating, and I actually created a dashboard where I had like temperature sensors on all the copper pipes in the heating room. And now I have like a Grafana dashboard, and I know what's going on in my heating. So next time the guy who installed the heating came, I said like, come to my office, I need to show you something. I opened it up and I said like, yeah, you know, there's this peak and there it gets too hot and then it throws an error. And he was like, I've never seen something like that before. And so we went down in the basement and he said like, you know what, I mean, you really know what's going on with the heating. You know, there's a password for the guys who install the heating. I can gladly give that to you because you really know what's going on. So you can change a little bit more things with your heating. And then after a couple of minutes, he was like, you know, we actually don't trust the people who install the heating because they have no clue. But you really seem to have the clue. And so there's another password for the manufacturer where you can actually change everything. So I got, you know, I own my heating now. It's like I have root access on my heating. Just because I added some metrics to my heating. And actually, during summer, I played around a little bit with it, and so I reduced the amount of energy used in the summer by 70%, and it was damn simple. Because there was just, you know, things going on, pumps that were, you know, pumping cold water through something that shouldn't get cold water. It was trivial just by looking at the, and then having some, you know, parts from China shipped and play a little bit around. If you want to know more, come to me later. I'm around today and I can explain to you a little bit about this. So this was my fun project at home. And now I'm owning my heating, and I mean, it's the same thing for you know, open source software somebody else has developed, but you're running in your data center or in production. And I think if you don't have an owner in your company for third-party or open source software, it's legacy from day one. Because those things nowadays, especially in the container environment, are in the container ecosystem, are developed so fast. So if you keep an old version of something, at some point it will, you know, create this bad locking of, you know, you cannot upgrade Docker because then this is not working. So the monitoring will not work, or the log collector will throw errors and stuff like that. So you need to keep all those components up to date all the time, because at some point you have like almost a deadlock of upgrades and you cannot move anymore. So you need an owner in your company for that. And yeah, obviously, as I said, like my heating is much more efficient now. You work on the right things. You know, I work in a startup. I don't have a lot of money to spend on my heating, I can improve it on my own now, and don't have somebody coming who just does something that has no effect. And you work on the important things, right? I don't have a lot of time to spend on it, yeah, it improves quality and your own speed a lot. So metrics first is really important if you do microservices. And just another example, Airbnb, they're running like 500 experiments on the platform every week, and they have like 2,000 business metrics around those experiments. And this is just an example of how you can do microservices in production and really find out what's going on, have tests, A/B tests, stuff like that, and measure them, and then move on and know your way, like your priorities, what you want to do next. And yeah, And just a brief overview of how you do metrics in Kubernetes and what's different from maybe other environments that you have used. So the important thing about metrics with Kubernetes is that you have a central orchestration, the service discovery, and those tools all integrate with that service discovery. So whenever you deploy a new service, it will be in your monitoring, it will be in your logging system. And this is kind of interesting. I mean, you can achieve the same thing if you automate services with Puppet, but it's just built in that Prometheus talks to the service discovery and that's it. And the only thing you have to do is having an endpoint in your service, for instance, /metrics, that delivers some information, some internals, be it non-functional or business metrics. It doesn't matter. Prometheus will come, catch those metrics, and you can create your dashboards and make it visible. And what's interesting is that you can have metrics from like cluster level down to like a process or a network connection. For instance, Sysdig as a tool has this nice, actually have a screenshot of it. So they have this ncurses top-like tool, which actually, so what he's doing here is, so you see things running in your cluster container, and then he goes to, yeah, open a bash shell in the container, please. And so you can have like a view of your cluster. Then you drill down in the cluster, look in a service. A service consists of multiple pods, which is multiple containers. Then you go into the container, and then in the container you have processes running. So you can drill down from a cluster view down to the actual process, and that's quite interesting. So you have like a top of your whole data center. And yeah, there are other tools like WeScope, where you can visualize which service is talking to which other service. I mean, we probably don't have this kind of Twitter like Destar or Airbnb or Netflix Destar diagrams pretty soon. I don't know if you've seen them. So Adrian Cockcroft does a lot of microservice presentations, and he presented the pictures which services at Twitter are talking to each other, and they all look like a Death Star because they organize the services, on a circle, and then they're talking to each other. And so he calls them Death Star architectures, and it's a little bit like that. But you can also just filter, for instance, here by having labels. So you filter all the services or the containers that have a certain label, and then you get a view how they are talking to each other. And yeah, this is about it. What I think is important about metrics in Kubernetes. Then the question would be like, how do I package up my apps to automatically have all these bits and pieces tied together? So obviously you need a Dockerfile to have a container image, and you need to define the service, which is probably, if your service needs a database or maybe something else as well. So you have a Kubernetes manifest where you declare, this is the Docker image I want to run. I want to run like 5 instances of it. I want to make it available under that port for other services, and I want to expose it to the public by having an ingress object with that domain attached, so it's accessible from the outside. So that's like the definition of your service, and then you need a metrics endpoint so that, for instance, Prometheus can collect metrics from the service. And what we usually do is also package up the dashboard with the service. So we have a Kubernetes job running that actually imports the latest dashboard into Grafana. So you deploy your application, and automatically the dashboard is updated as well. And then you need to define some labels for your containers to actually make them, discoverable in the whole infrastructure. The best thing is actually to establish that across teams, to have like a way how you define labels to make things discoverable for I don't know, your product management or your architects, and to help them discover services and look into it, or for your ops, obviously. And so there's the CNCF, which is the Cloud Native Computing Foundation. That is the foundation that adopted the Kubernetes project and also Prometheus. And so they're working on recommendations. They're not working on standards for deploying apps, but they're working on telling people there are multiple options, because in the container ecosystem there are currently lots of different tools, and they adopted 2 tools, but they're also saying that there are more, and it's not only one to rule them all. There's something like the label schema from I think Puppet and Micro scale in London, and microscaling, and so that's like a first prototype of a recommendation how you should create labels for your containers. And there are obviously a lot of special interest groups in Kubernetes that think about this topic, so SIG apps is, for instance, one, how to package up apps and have them in a catalog. And yes, probably the best thing is to establish your own practices, to establish your own, what kind of metrics, how are they named, to make them discoverable across services. That's something that you need to find out for yourself. Yeah, and the last thing is, again, some non-technology, but the most important problems we see with companies adopting microservices is communication, culture, and we have 2016, and if you don't do agile or haven't done it at least once in a project, you probably missed the train 15 years ago. I don't know, I have to talk about those practices still, but I actually don't want to talk about that anymore, because I think it's 2016 and everybody should have of it, and everybody should be doing it in his own way, and be Scrum or Kanban or whatever it fits in well. But we should all write tests and have common practices around coding. But there are other things we can do. What I really like is to encourage the people to play around. Having a culture of fear doesn't help. You have to encourage people to actually play around and start trying something out. Not without thinking. That's what I said before. You obviously have to think about what you want to implement, but then start doing something and don't talk about it. Don't talk about it for half a year. Just try it out and learn. That's very important. And also something I like to do. Even so, we're doing this kind of Kanban style where we still synchronize every week. And look if there's enough in the backlog. But the most important part of that synchronization meeting, which is the only one for the team, is the retrospective. So we look at what has been done, not what has been done, but what happened within the last week. This is part of many of the agile practices, but I made the experience that sometimes people forget about this retrospective, and So having a retrospective and talking to your team, what's actually going on, is a key part of learning together and solving also the non-technological problems. And the other thing is, like, you know, if shit hits the fan, and do a postmortem, look at it closely with the whole team, analyze what's going on, find the root cause, not just fix some symptoms, and make this an important part because otherwise you will just drown in technical debt. But you should actually, you know, with this microservice, you should build technical wealth and not drown in technical debt. And so if you find yourself in a situation where you're just firefighting and, you know, fixing symptoms and not root causes, then your microservices are just bound to fail. And we also do something like architecture reviews. So once in a month, we sit together and think about the architecture. Like, what have we learned? What can we improve? It's more like it's not what we do next week, but it's more like a longer roadmap of things where we already anticipate that, you know, this part is working fine, but we can already anticipate that it's going to not scale any further or something like that. Or this is just, you know, taking away time every week and it's just annoying and we have to fix that or recreate the service. And and let's do that together with the team and let the team define the goals, because they are actually developers that know what's going on. They run their own services. They pretty much know where their pain points are. You know, where it's hard to implement a new feature, where it's hard to keep the service up. And so do it with the team together. And draw a lot. So if you're in an office, you know, draw a lot on the whiteboard. But if you're not, if you're remotely like we are, use tools like Draw.io or whatever, and draw something together to actually have something visual to discuss about. Because you can easily just, you know, discuss an hour and talk about the, you know, different things. If you have not visualized it, it's much simpler if you draw something on a whiteboard and everybody has, you know, the same notion. And the last most important thing is celebrate more. You know, with the team, you know, be happy about what you achieved, and, you know, that's the most important thing. Sometimes you forget what you have achieved and you see just the mountain in front of you. You still have to run on. And thanks for listening.
We will take 3 questions. So, 1.
Hi, Timo. Hi, Timo. Thank you a lot for your presentation. First of all, I don't have any experience with Kubernetes. I'm not sure. From my understanding, it's like a cluster manager or a container manager. My question is, how do you actually host Kubernetes? You have your own data center, or you have some infrastructure as a service, some platform as a service? And if yes, like, have you tried Amazon Container Service, ACS? And if you had any experience, what was that? Thanks.
We run Kubernetes in both like cloud environments and in our own data center. And in our own data center is actually on physical machines. And we use a CoreOS for it. So we also have the underlying platform is also like, we have an image. So same principle, having a mutable image, starting a CoreOS version, and then starting containers on top of CoreOS that bootstrap Kubernetes. And there's even a more complex version of it where we start multiple Kubernetes. So it doesn't matter where you want to deploy Kubernetes. You can use most of so you can use Azure and Amazon GCE. GCE also has like a managed master for you. AWS doesn't have anything prepared, but Kubernetes has, for instance, storage drivers to talk to the EBS storage volumes. So there's an integration of Kubernetes talking to Amazon Web Services, and also for the networking, I think. And yeah, it's pretty much up on you what you want to use. ECS compared to Kubernetes is really basic. It really depends on what you need. So yeah, we've had customers running on ECS as well. You start EC2 instances and then you launch a container on it, and Amazon just helps you a little bit with that. But if you look at what kind of services Kubernetes provides, it's much more mature and it has much more features. And it's also, agnostic from cloud provider.
Thank you.
So, because we ran out of time, you can find Timo at the break, in order to take a break and be back in 20 minutes. Okay? Give a warm applause to Timo. Thank you.